Okay, so go ahead and multiply this out now. The first problem is 2x squared y multiplied by the quadratic 4xy minus 7xz. Okay. I'm going to rewrite that over here. So I can stay out of the screen a bit, stay out of the way as I can. Right there is your expression. Okay, well, by the distributive law, we multiply this by this, and then we multiply this by this, and subtract. This would be an instance of A times B minus C equals AB minus AC. Okay, so AB, we're going to do that. We're going to do 2x squared y multiplied by 4xy. And then minus AC would be minus this times this. Minus 2x squared y times 7xz. Well, I multiply this out, 2 times 4 is 8. X squared times x is x cubed. Y times y is y squared. And then 2 times 7 is 14. X squared times x is again x cubed. And y times z is just y z. And there we have the product by the distributive law. And the laws of factorization. Okay. Now, let's look at this. I'm going to tell you that x to the fourth y cubed plus x squared z can be written as x squared plus something. So what goes here? What would you multiply x squared by to get x to the fourth y cubed? What would you multiply x squared z by? I'm sorry, what would you multiply x squared by to get x squared z? Okay, see if you can puzzle that out in the next couple of minutes. Okay, now some people might have a little trouble with that. Let's say, take one term. We've got x squared y to the fifth, right? What would you multiply by x squared y to the fourth? Sorry. What would you multiply x squared by? Yeah, that's not a good question. We use a higher power. What would I multiply x squared y by in order to get x to the sixth, y to the fourth? Okay. So we see that what do we need in here? We need to get x to the sixth. We've already got x squared. So it's like we got two x's multiplied together here. We need 6 of them. It means we're going to need 4 of them. And then y to the fourth, we need to get a y to the fourth. We've already got 1 y. We need 3 more. Meaning we need y to the third. Okay. Now over here, what would we multiply by x squared? Get x to the fourth, y to the third. That's what we go here. Okay. So we can even kind of make a note here. X squared multiplied by what equals x to the fourth, y to the third. What we need in here in order to get this. Okay, so we did pretty well with that. X squared times what equals x to the fourth, y cubed. You'd say x squared. Now, the first answer I got from some people is just x squared times x squared equals x to the fourth, y cubed. Well, that's not quite right. X squared times x squared is just x to the fourth. Of course, that's what you were focused on if you got that answer. And that's correct, but you also need y cubed. Okay. Now that times that equals this. So here I can say that this is x squared times x to the fourth, y cubed plus, okay, well now what do I need to multiply by x squared here to get x squared z? Can you write that down? Okay, so we can isolate this. X squared times what now equals x squared z. So we can write that x squared times what equals x squared z. And the answer is fairly simple. If you multiply x squared by z, you get x squared z. You don't need an x here. And I wrote something down wrong here. I said that was x to the fourth y cubed, because I was looking at this, but it's obviously x squared y cubed. So now I mistakenly wrote something down wrong here. Let's just check this out to make sure it works. I multiply x squared by x squared y cubed. Do I get x to the fourth y cubed? Well, yeah, x squared times x squared gives me x to the fourth. I've still got my y cubed. Then x squared times z gives me x squared z. So we can check it out. I'm sorry, I kind of screwed that up, so that could be misleading. Just wrote it down carelessly. All right, let's try another one. Let's try. Okay, let's see if we can do this. What would I multiply a squared, b squared, c squared by in order to get a cubed, b squared, c to the fifth plus a squared, b cubed, c squared? Okay, 6x squared plus 8x plus 12. Now, we're going to be dealing with numbers, and not everybody has all the multiplication facts at their disposal, especially when we get into bigger numbers. So we're going to start with some simple numbers here. 6x squared plus 8x plus 12. And we want to look at 6. We want to look at prime factorizations. I'm just going to lift the main primes that we'll be dealing with, okay? Now, these are all numbers that can't be divided by any other number evenly. Okay, there's nothing you can divide by 3 to come out with an even number. Same with 5, 7, or 11. So we really need to remember these numbers or have a list of them if we don't totally understand that. Okay, so we're going to take 6. Here's our rule. First thing that we do is divide by 2. Okay. So if you need to use your calculator, okay, we're going to take 6. Okay. Prime factorization of 6. We're going to do 6 divided by 2. What's that equal? You hold up your fingers when you get it. It's 3. So 6 equals 2 times 3. If 6 divided by 2 is 6, but if you multiply both sides of this by 2, you get 6 equals 2 times 3. And of course, you can verify that. You need to use your calculator. 6 is 2 times 3. Okay. So we're done. What's prime factorization of 8? Well, we divide 8 by 2. What do we get? Okay, so 8 divided by 2 is 4, so 8 is 2 times 4. 2 is a prime number, so we don't try to divide it by anything because we can't. But we take 4. 4 divided by 2 is 2. So and need to write an extra step here. I'm kind of used to skipping, but we need to do this. So 4 equals 2 times 2. So 8 equals 2 times 2 times 2. Because of course, 8 equals 2 times 4, and 4 equals 2 times 2. So instead of 4, I can write 2 times 2, and that's how I get this. And of course, that's 2 to the third power. Okay, well, let's try to do the same thing with 12. Here's your starter. 12 divided by 2 equals what? Okay, so 12 over 2 equals 6. 12 equals 2 times 6. So we got that. Okay, now 6. We divide 6 by 2. And what do we get? And what do we conclude? Okay, so 6 over 2 equals 3. I'll write the smallest prime first, usually 2 times 3. So 12 equals 2 times 2 times 3. Okay, now we can make a kind of a tree diagram. Another way of doing, okay, let's do the prime factorization of 6. Well, 6 equals 2 times 3. Prime factorization of 8. First thing we did was 8 equals 2 times 4. That's what we get when we divide by 2. We can divide by 2 again into the 4. And we get 2 times 2 times 2. And this is the way you're going to see it, I think, in open math, depending on which video you choose to look at. And then here we got 12. We divided 12 by 2 to get 6. which means that 12 is 2 times 6. And then we divided 6 by 2. And we got 2 times 3. And we still have the 2. So, 6 is 2 times 3. The 2 is still a 2. 2 times 2 times 3. Now, another way to write this is 2 squared times 3. So when we come up here, we can write 6 as 2 times 3 times x cubed. And then 8 is, I don't want to write it that way. I want to write it as 2 cubed. Okay, so I've got a 2 cubed times x here, the 2 squared times 3 here instead of the 12. Of course, I've still got my x, and I've still got my x squared, not x cubed. Now, I can factor out squared. Wait a minute, we can't factor out 2 squared, factor out 2. Okay. Now what that means is 2 times what is going to give me 2 times 3 times x squared. And then 2 times what's going to give me 2 cubed times x, and 2 times what is going to give me 2 squared times 3. Okay, now might be a little confusing because the numbers look different in symbols, but what we need is 2 times 3 times x squared, okay? Now, if we multiply 2 times 3x squared, don't we get this? This is 2 times 3 times x squared. This is what we need. So what would we multiply 2 to get 2 cubed times x? Well, if we multiply 2 times 2 squared, we get 2 cubed, right? And then we have our x. And then what would we multiply by 2 to get 2 squared times x? That would just, our 2 squared times 3, that would just be 2 times 3. And then this gives us 2 times 3x squared, 4x plus 6, because now we can multiply these things back. The point is that if we treat these numbers, these prime numbers, the same way we treated symbols over here, we get it. And what did we get here? I forgot to complete this, but we got this correctly. Everybody got this correctly. A squared times b squared times c squared. Well, we need a cubed, so we need an extra a. We have a squared, we need a cubed, we need an extra a. We have c squared, we need a c to the 5th, so that would be times c to the 3rd. And over here, we have an a squared. Well, we have a squared here, we need a squared here. We don't need any more a's. We have b squared, we need c cubed, b cubed, we get a b. And we have a c squared, we have a c squared here. We don't need any more c's, so there it is. If I multiply this out, we get this. That's the idea. Now that's one kind of factoring. We need to move on and talk a little bit about factoring trinomials. Okay, and our first task will be to use the distributive law to multiply out this pair of binomials. Okay, it appears that everybody's on track to get this. And I'm going to use the distributive law, and then I'll do it the way I see most people do it. And we've seen this before. X plus 4 multiplied by x plus 3 means x times x plus 3 plus 4 times x plus 3. There we have it. And of course, x times x plus 3 means x times x plus 3x plus 4x plus, I'll write it out as 4 times 3. We write that as x squared, 3x and 4x gives us 7x. 4 times 3 is 12. Now let's notice something. Okay, another way I see people do this is they do this, and then they do this and this. Comes out the same way. We get x times x is x squared. X times 3 gives us the 3x. 4 times x gives us the 4x. And 4 times 3 gives us the 12. I'd like to see people write out the distributive law because it shows more depth of understanding. But this is the way it looks, it's the way it feels. I did it myself when I was learning algebra. Okay, but of course I knew how to do it this way too. It's important to know how to do both. Okay, so we get this. Now let's notice something. Where did that 7 come from? Well, the 7 came from the 3 and the 4 on the x, right? So 7 came from the 3 and the 4. And where were the 3 and the 4? Well, they were here and here. Okay. So notice. I'm going to say that 7 equals 3 plus 4, which is in the original expression, x plus 4 times x plus 3. And I'll put the underline. I had it here, but let's make sure we see where it comes from. Okay. And then where did the 12 come from? Well, the 12 came from the 4 times the 3. It came from the 3 and the 4. Okay. So the 12 came from the 4 and the 3, but we multiplied them. Well, it's 3 times 4. Okay. I'll say we also see this in the original. And I'm writing this in blue, underline these in blue, came from the 4 and the 3. We could say that x squared is 3 plus 4 times x plus 3 times 4. Now here's what's going to get a little tricky, a little ugly on the arithmetic. I'm going to write x squared plus 5x plus 6 equals x plus a times x plus b. And if we multiply this out using the distributive law, we're going to see that x is going to multiply x to give us x squared. A is going to multiply x to give us a times x. And b is going to multiply x to give us b times x. So we're going to get a plus b times x, same as our 7x came from adding the 3 and the 4. Whatever's in front of the x comes from adding this number to this number. Similarly, this last number is just a times b. And that's what we get when we multiply these two numbers. So we want a plus b to equal 5. And a times b equals 6. Now, two numbers could be multiplied to get 6. Means as they could mean a equals 2, b equals 3. It could also mean that a is 3 and b is 2, but that comes out the same. That doesn't matter. Okay. One of the numbers could be 2, the other could be 3. Or a equals 1 and b equals 6. Now, if a equals 2 and b equals 3, well, let's say if a equals 1 and b equals 6, let's just start with that, which is the last one we looked at, okay? A is 1 and b is 6. Then what's a plus b? Can you show me with your fingers? Okay, I see 3, but a plus b would be 1 plus 6, right? What's 1 plus 6? 7. Okay. Okay. So if a is 1 and b is 6, a plus b is 7, which means you have a 7 in front of x, right? Okay. Well, do we want a 7 in front of x? No, we want a 5. Okay. Now notice where we are. We're assuming that a times b is 6. And we get two pairs of numbers that make that so. So we've already got 6 if we use 1 and 6, or if we use 2 and 3. If we use 1 and 6, then what we get in front of x is 7, because a plus b is 7. Okay, what do we get if a is 2 and b is 3? What's a plus b? What's 2 plus 3? 5. It's 5. 2 plus 3 is 5. Okay. So If A is 1 and B is 6, we get A plus B is 7. That's not good. A is 2 and B is 3, then A plus B equals 5. Okay. So x squared plus 5x plus 6 is x plus A plus times x plus B. But now we've determined that A has to be 2 and B has to be 3. And there we have it. If x A is 2 and B is 3, this multiplies out. And let's multiply that out to check. What do you get if you multiply x plus 2 times x plus 3? Okay, now take this problem, factor x squared minus x minus 6. Okay, minus 6 could be a number of things. It could be minus 2 times 3, or 2 times minus 3, or minus 1 times 6, or 1 times minus 6. Those are all different ways we could get minus 6. Now, there are only 2 ways we could get plus 6. But there are 4 ways we could get minus 6 because of the minus sign. One of the 2 numbers has to be negative. That kind of doubles our possibilities, okay? So I'm listing 4 ways this could work out, depending on which pair of numbers we choose. Okay, well, if I multiply this one out, first one, and we're going to have to just go through this. I'm not going to be able to give people time to work it out, but watch carefully what I do. We get x squared from the x times x. We get minus 2x, and then we get plus 3x. We get minus 6. If we just multiply everything out carefully, this is what we get. And we get x squared plus x minus 6. That doesn't match up. We need x squared minus x minus 6. That's not quite right. We get a plus x instead of a minus x. But let's try the last one. The first one didn't work. Let's try the last one. We do x plus 1 times x minus 6. X times x is going to give us x squared. And 1 times x is going to give us just plain old x. And then x times minus 6 is going to give us minus 6x. And 1 times minus 6 is going to give us minus 6. Well, x minus 6x is minus 4x. No, it isn't. It's minus 5x. I'm going to put a note down by that one. That one didn't work out. Okay, we tried the first one, the last one. Let's try the second one, and then hopefully if that doesn't work, the third one will. Well, the second one, if you work it out, gives us x squared plus 2x minus 3x minus 6. And that matches what we need. So x squared minus x minus 6 is x plus 2 times x minus 3. Well, the assignment is to learn to do this with a bunch of different examples, okay?